Hey there, and welcome. Today, we're going to break down one of the classic challenges in all of computer science, the reader's-writer's problem.
Okay, so let's just dive right in with a question. Think about any busy website, from a railway booking site to your social media feed. How do you manage all that traffic? All those people looking and changing things without the data just turning into a corrupted mess?
All right, to really get a grip on this problem, we first need to meet the two key players in this little drama, who are both competing for the exact same thing. So where does this all happen? Well, the battleground for our players is some kind of shared database. A perfect real-world example is a site like Indian Railways, where at any given moment, millions of people might just be checking a train status while others are trying to book a ticket.
Now, on this battleground, you've got two types of processes. On one side, you have your readers. They're just window shopping. They only want to look at the data, like checking that train schedule. And on the other side, you have the writers. They're here to make changes, like booking a ticket, which actually modifies the number of available seats.
So here's the million-dollar question. When can these guys, the readers and the writers, access the database at the same time, and when does it all just fall apart?
As one source puts it so well, letting anyone else access data while a writer is in the middle of an update can lead to chaos. I mean, imagine you're trying to snag the last ticket on a train. If you read the seat count just as someone else is booking it, you might see one available, when in reality, it's already gone. That's the kind of mess we need to prevent.
This table here, it lays it all out perfectly. If you have a bunch of readers at once, that's totally fine. They aren't changing anything, so no harm, no foul. But the second you introduce a writer into the mix, you've got trouble. A writer and a reader at the same time can cause a dirty read, where you see data that's only halfway updated. And two writers at once? That can lead to lost updates, where one person's change just gets completely overwritten. It's like it never even happened.
So how do we stop this chaos from happening? Well, we need a system of rules, a synchronization method. And the classic solution uses this really clever toolkit based on something called semaphores. You can just think of them as super smart locks or traffic signals.
Our little toolkit has three main parts. First up is a semaphore we'll call DB. This is the big one, the main lock for the entire database. If a writer has this, nobody else gets in. Then we have a simple integer, RC, that just counts how many readers are currently inside. And finally, to make sure we don't mess up that count, we protect it with its own tiny little lock, a semaphore called mutex. Okay, so we've got our tools. Now let's put them into action and walk through step by step to see how these pieces work together to keep everything running smoothly. All right, picture this. The very first reader shows up. First, it briefly locks the counter so it can safely bump the read count up to 1. Now here's the key move. Because it's the first reader, it immediately grabs the main database lock, the DB semaphore. It's like putting up a big Do Not Disturb sign for any writers. Then it unlocks the counter and goes about its business. And this is where the protection kicks in. If a writer wanders along right now, it hits a brick wall. It tries to get that DB lock, but nope, it's taken. So the writer process is basically put on hold, forced to wait its turn.
Okay, so what happens when a second reader comes along? Well, it also locks the counter, bumps the count up to 2, but look, the code that checks if it's the first reader is false. It's not the first reader, so it doesn't need to lock the database again. The first reader already took care of that. So it just unlocks the counter and waltzes right in. And this is the really beautiful, elegant part of this whole solution. It basically creates a reader's party. Once that first reader is in and has locked out any writers, any other reader can join the fun. The door stays wide open for them, but it's firmly shut for any writers waiting outside.
So you're probably wondering, when does the poor writer finally get a turn? The magic happens when the party's over, when the very last reader leaves. As it's heading out, it locks the counter, lowers the count, and when that count hits 0, that's the trigger. That specific reader is now responsible for unlocking the main DB semaphore.
Think of it like turning the lights back on and taking down the Do Not Disturb sign. The database is now totally free, and that writer who's been waiting so patiently, it can finally wake up, grab the lock, and get the exclusive access it needs to do its job.
So this is a pretty neat little algorithm, but why does it matter so much in the real world? It all comes down to one crucial thing: data integrity. This pattern, or something very much like it, is running under the hood in operating systems, in databases, in pretty much any complex system you can think of. It makes sure that when important data is being changed, it's done in a protected little bubble, preventing those nasty errors that can bring a whole system crashing down. All right, so let's boil it all down. The takeaways are simple but really powerful. For efficiency, we let a whole bunch of readers in at the same time. But for safety, we always give a writer exclusive private access. And the whole trick hinges on two key roles. The first reader to arrive acts as the bouncer for writers, and the very last reader to leave is the one who opens the door back up for them.
And that leaves us with one final nagging thought. This solution is great, but you might have noticed it really rolls out the red carpet for readers. So in a super busy system, what happens if new readers are just constantly showing up, one after the other? That poor writer could be left waiting forever. That problem has a name. It's called writer starvation. But how you solve that? Well, that's a whole other puzzle for another day.